one on page 327 says, express 60.1 calories of energy as units of joules. This is really easy. It's just a straight conversion. So we have question mark joules, which is capital J, equals 60.1 calories times, and we have this conversion factor right here.
So we have to memorize 4.184.
4.184 joules per calorie. You should memorize that, yes, because it'll come up frequently. Okay. And then we're going to multiply. We're going to cancel our calories. Whoops. Okay, wait a minute. There we go. Okay. We're going to cancel our calories, and it's just going to be a straight multiplication. So we're going to end up with 251 joules. Okay? Any questions on that one? Everybody got that?
No.
So is this like a kilocalorie, as we understand? Like
No.
calories?
That would be a capital C calorie.
Okay.
Kilocalories are signified with a capital CAL. If it's lowercase CAL, it's just a regular calorie.
Okay. And
Food calories are kilocalories.
yes, that's what I said. Okay.
So what are these calories?
Just regular calories.
The amount of energy needed to raise 1 gram of water or 1 milligram?
1 gram.
1 gram of water, 1 degree Celsius.
Okay, and pay attention to this because these two terms, if you did not pay close attention in your notes, a calorie is, as Zach just said, the amount of energy needed to raise the temperature of 1 gram of water, specifically water, that's important, by 1 degree Celsius. Because over here, we're going to have someplace. We're going to be looking at specific heat. Where did that go? Oh, right here. Yeah, specific heat capacity on page 329 is the amount of energy needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. So, a calorie is basically the specific heat of water. Okay, so those two terms have very similar definitions. If it says water, it's a calorie. If it says a substance, then you're talking specific heat. Nick, did you have a question?
So basically one of the calories as we think of them in food would actually raise the temperature of a gram of water 1,000 degrees Celsius.
Right, exactly. Okay, does anybody have any other questions? We're ready to go on?
Ready.
Okay, good. All right, so example 10.2, which is on page 328, says, determine the amount of energy in joules required to raise the temperature of 7.40 grams of water from 29 degrees Celsius to 46.0 degrees Celsius. Okay? And so we have here question mark joules equals, and I probably would have started right with my grams, but I just wrote it the same way that the book does. So we have 7.40 grams right there, okay, times, okay, we have to have our temperature. All right, and so in order to figure out the change in temperature, you have to subtract them, and I think, did they give you a, no. So we have 46 minus 29, so I'm going to rewrite this here. So we have 4.184 joules per calorie, because it's water, times 7.40 grams, times, and what is this temperature difference going to be?
17.
Yeah, 17. Hold on a second. Times 17 degrees Celsius. That should be 17.0. Sorry. Degrees Celsius. Okay? All right. Okay, and this is also, we can also write this as, this doesn't work. Because a calorie is the amount of substance needed to raise 1 gram of water or 1 degree Celsius, we can also write this as joules per gram degrees Celsius. Okay, and that makes the units cross out better. So let me go back over here. All right, so now our grams, let's try that again. Okay, now our grams are going to cancel with our grams. Degrees Celsius cancels with our degrees Celsius, and we're going to get.
So 1 calorie can always be substituted for grams degrees Celsius?
Yeah.
Miss Kimmy?
Yes.
Where's 17?
Are we supposed to ignore the blue? Or like, what are you doing?
I just rewrote this right here, but this came from this.
Oh.
See, 46 minus 29 equals 17.
Looks like grams Celsius thing at the beginning.
Okay. All right. So here, let me write this right here. Okay. So 1 calorie equals 1 gram degrees Celsius. Okay. So I just substituted that for that because that makes my units cancel. So those are the same. Okay. And then this right here becomes that.
17 point
It's a 17.0 degrees Celsius.
degrees. I thought that was 6.
I thought that was a G and a D. And I was like, what is 70? What is it? 0.06.
Okay.
Is that what you said?
Yes. No.
0.0. It's a degree sign.
Let's fix it. So since nobody can read it. Okay.
I can read it.
Stop it there, guys. I can read it.
It's trained to me. 17.0.
I was like, you get it. You said check out.
17.0 degrees Celsius. There. Is that better?
Yes, miss.
Okay. And now I'm going to cancel my degrees Celsius. Okay. All right. And so I'm going to end up getting here 526 joules. Okay? All right. Does everybody understand what I did here now? Emily?
Will there ever be times where it'll be like point, or like 26.7 joules, or will it always be a whole number?
No, it's not going to always be a whole number. Yeah.
So, from when it said like water from 29.0 to 46.0, you always subtract the small ones from
Are those of you in the front row having trouble with this equation? Because Lauren is, and she's asking me a question. Thank you. Lauren, what was the question?
You always subtract the smaller from the bigger one.
Yeah, because otherwise you'll get a negative number.
So I always want a positive number.
Yeah, and in this case, you're going to always want a positive number. Okay. All right, so, and plus, remember I said that heat always flows from the hot to the cold. So since heat always flows the one direction. All right.
Question.
Yes.
So when you put ice in a drink,
When you put ice in a drink, the heat flows from the drink to the ice.
then why does the drink get cold?
Because the energy.
Why does the drink get cold? Because as the heat flows into the ice, it melts the ice, and now the energy is not available in the drink anymore, and so the temperature of the drink has been lowered. Okay. All right, so example 10.3 on page 330. All right, what quantity of energy in joules and in calories is required to heat a piece of iron weighing 1.3 grams from 25 degrees Celsius to 46 degrees Celsius? Okay, so we have the same kind of situation as we just did here. We're looking for joules, and in this case, we're using specific heat. You can find the specific heat chart on page 329. It's table 10.1, and it'll give you the specific heat of anything you need to know in this chapter. Obviously, there are tables of more specific heats that you can find elsewhere. But so the specific, let me try that again. The specific heat of iron is 0.45 joules per gram degree Celsius. Okay? All right. So I'm going to work out this work here. So I'm going to have 0.45 joules per gram degree Celsius times 1.3 grams times, and what is my temperature difference going to be here? 21 degrees Celsius. Okay, so now I'm going to cancel. Here's my degrees Celsius, there's degrees Celsius, there's my grams, there's my grams. Okay, so I'm going to end up with then 12 joules. Okay? And now to figure out the calories, I'm going to take that 12 joules and put it right here. Okay? And I've gotten this upside down. Yeah. Okay, you guys know what that means, right? I wrote it upside down. That's what it means. Okay, so now, all right, so now my joules and my joules are going to cancel. There. And I have 12 divided by 4.184, and that is going to give me 2.9 calories. Okay, any questions there?
What page is all the specific heat on?
Specific heat table is on page 329. Okay. Okay. How are we doing on time? Okay, I'm going to try and get through one more, but I haven't written it out, so I'm just going to... All right, so if we go on to example 10.4. On page 332, okay, we're going to be using this equation here. You should also memorize this equation. Q equals S times M times delta T, which is pretty much what we've been doing, where S is the specific heat, and M is the mass, and delta T is going to be the what?
Temperature change.
Change in temperature. Right. Okay. All right, so example 10.4 says you have a 1.6 gram sample of a metal that has the appearance of gold, requires 5.8 joules of energy to change its temperature from 23 degrees Celsius to 41 degrees Celsius. Okay? Is the metal gold? Okay? Specific heat for each metal is specific to that metal. Okay? So what we're looking for here is the specific heat. So we're going to solve for S. Okay? So S is going to equal Q times 1 over the mass times 1 over delta T. Does everybody follow that? Tabby?
Why'd you do the 1 over?
Because it's Q divided by that, but it's easier to keep it in an equation that way.
I still don't understand.
Okay, if I'm solving for S, I'm going to take Q divided by M divided by delta T, right?
Yeah.
Okay, so this is the same as Q divided by M divided by delta T.
Okay.
You could just put it, you could do it this way.
There's a lot of humps for me.
It's fine, whichever way you want to do it.
It's just 3.
One too many.
Okay,
Not in cursive.
alright, so Q, what is Q?
Huh?
Sorry.
I don't know what Q
Q is the energy. Okay, so in our equation, what is Q?
Money in cursive.
5.8.
Right, so we have 5.8 joules. I'll do it this way to make it simple for you. Divided by, what's the mass?
1.6.
1.6 grams. Okay, and what's our change in temperature?
18 degrees Celsius.
18 degrees Celsius. Okay, so when we calculate that out, I've lost my place, I apologize.
Okay.
Yeah,
You are the door to learning, but not a window to the world.
sorry. Okay, so now we have 0.20
Wow, same.
joules per gram degree Celsius. Okay, when we calculate that out, and then we can flip over to our heat capacity table on page 329. And look it up and see that the heat capacity for gold is actually 0.13, and so this is not pure gold. Okay. Your assignment is going to be to do notes on 10.2, section review, and the chapter assessment for 10.2. It's not stupid. 1, 2, 3, 4, 5, 6, 7. There's 7 problems.
We'll fix that problem.
Plus the review.